Hello friends, let's have some discussion on dynamics part also. So here I am going to discuss the kinematics of rectilinear motion and with motion with uniform acceleration UAM case. So we know that we have three equations for uniform acceleration motion, and these equations are being derived from the basic principles, and that is also important. So please look the derivation part of these three equations in any book and prepare it well. If you remember these three equations, you can solve the problem related to UAM, that is motion with uniform acceleration. So first equation is V equals to U plus AT. Second equation, S equals to UT plus half AT square. And third equation is V square equals to U square plus 2AS, where U is initial velocity, V is final velocity, A is acceleration, T is time in seconds, then S is distance. So these are the nomenclature we have used. Some books may have different nomenclature. For distance they use x or any other term, right? So it's not problematic. So try to understand and don't have a confusion. So let us solve one simple problem related to UAM. A car starts from rest and accelerates uniformly to a speed of 80 km per hour over a distance of 500 meters. Calculate the acceleration and time taken. If further acceleration raises the speed to 96 km per hour in 10 seconds, find the acceleration and the further distance moved. So this is the problem given, and you might have understood the problem has given two cases. In first case, the car starts from rest and accelerates uniformly, and from this you have to understand that this is a question of UAM, right? Uniform acceleration motion. So here it is accelerates uniformly. When it says like this, it means it is a question of UAM. Try to understand. So let us solve this problem one by one. So let us touch to the case number 1, right? So case 1, when the car starts from the rest, so it means initial velocity is equals to 0, because car is starting from rest. It means it is at stagnant position, it is at rest, means initial velocity is 0. Then it accelerates uniformly to a speed of 80 km per hour. It means final velocity reaches to, so you can say here U, and here final velocity you can say V, right? And that is 80 km per hour. But we want the velocity in meter per second. So it is better to convert this. So there are two ways. The first way is just convert kilometer to meter by multiplying 1000 and hour to second by multiplying 60, dividing 60 by 60, or simply you can use calculator, right? And what you can do is you can use a factor, that is 3.6. so what I can do here, 80 divided by 3.6, you can check both, right? So you will get the same velocity in meter per second. So I am using both the techniques, okay? Whichever is convenient to you, you can use that particular one. So 80 multiplied by 1000 divided by 60 multiplied by 60, it is coming to be 22.22, and by this technique, by this shortcut, right? We can see 80 divided by 3.6. So simply use 3.6 in denominator, right? So you will get the same and you can save some time here. So 80 divided by 3.6 or any value divided by 3.6 will give you velocity in meter per second. So this is how, right, calculate the velocity in meter per second. Don't take the value of velocity in kilometer per hour. Okay, don't do that mistake. Many students do this. Now one more thing is given, that is distance traveled. So S is given, that is 500 meters. So distance is in meter is okay because we are taking velocity in meter per second. So distance will be in always in meter unit. Okay, so there is no need to convert this. Now what we have to find? We have to find number 1 acceleration and number 2 time taken. These two things for case number 1. This second case we will discuss later on. First let us find A and T. So you know the equations now. We can use the, because we have final velocity, initial velocity is 0, we have been given distance and we have to find A. This A we have to find out. So we can use this equation first. So let's see. So I am writing equation here. So V square equals to U square plus 2AS. This is the equation I have to use. Final velocity I know, that is 22.22 square equals to 0 because initial velocity is 0 plus 2 into acceleration I have to find, multiply by 500 because S is given 500, right? So hope it is clear to you. So just solve this. So you will get 22.22 square equals to, right, divided by 1000. So acceleration is coming. So what I have done, simply I will tell you, square, I have taken the square of this. This is 2 into 500, so it is 1000. A equals to 22.22 square. Hence A equals to, right, 22.22 square is coming 493.72 divided by 1000. So A is coming divided by 1000. So it is 0.493 meter per second square. Always write the unit. So this is the first answer expected. I hope it is clear. Now we have to find the time, right? So we can use the next equation, and that is, now we have acceleration with us, right? So only the T we have to find. Final velocity we have, initial velocity we know, that is 0. A we have, so we can use the next equation, that is V equals to U plus AT. So V is, just substitute the values now, 22.22 equals to 0 plus A is 0.493 multiplied by T, and hence T equals to 22.22 divided by 0.493, and using calculator we can get 22.22 divided by 0.493 equals to, so time taken, okay, to raise this particular speed, this to attain this final speed is 45 second, 45.0 second, right? So this is the answers for first condition. So I hope we have justified, right? We have been asked to find the, you can see here, we have been asked to find the acceleration and the time taken to attain this speed. Okay, so you can see this is the first answer and this is the second answer. Now let us touch to the case number 2. In case number 2, it is given that, let's read the problem again. Okay, it is given that if further acceleration raises to the speed to 96 km per hour. Now from 80 to 96 means they are further increasing the speed by 16 km per hour. in 10 seconds. You have to understand this, right? It is not the case now starts from rest. From 80 km per hour to 96 km per hour. That is the thing we have to understand here. Okay, and that too in 10 seconds, right? So for this we have to find the acceleration. Now we have to find acceleration here and the distance covered with this velocity, right? Okay, so I hope you understood the problem. So now here initial velocity will become, so I will write case 2. In case 2, first we have to see initial velocity. Now initial velocity, u will not be 0 here. Now u will be what? The earlier final velocity, and that is 22.22 meter per second. See, we have we have taken in case 1 the final velocity as this. Now this will become the initial velocity here in this case, because it is not starting from rest. They are further accelerating the vehicle or car and attaining the final speed of 96 km. So here final velocity will now be velocity v equals to 96 km per hour. So convert to meter per second. So 96 divided by 3.6. So I am getting 96 divided by 3.6. 26.66 meter per second. I hope it is clear. And time taken t is given, that is given in the problem, that is 10 seconds. So simply write here time taken is 10 seconds, right? So this is what is the condition is given. Now we have asked to find the a and the distance covered. These two things are asked. Find the acceleration and the further distance moved. How much distance has been moved by the car with this particular velocity, right, or speed. Okay, so here we can use the equation v equals to, because we know we know v, we know time, so we can use v equals to u plus at equation, right? Only a is unknown here, so simply substitute the values. 26.66 equals to 22.22 plus a, and time is 10. So simplify this. So 10a equals to, this term I am bringing here, 26.66 minus 22.22. okay, and we will get a equals to 26.66 minus 22.22. so 4.44 divided by 10, and a equals to 0.444 meter per second square. This is the acceleration. This is the expected answer, right? Now we have to find distance traveled or distance moved with this acceleration, right? With this acceleration. So let us use a equation, because we have to find the distance. We know the u, we know the acceleration, we know the time. So we can use equation s equals to ut plus half at square. So s we have to find simply. U is what? It is 22.22. So simply write here 22.22 into t is given 10. So 10 plus half. A we just now calculated 0.444. Simply write into 10 square and simply solve this equation, right? So you will get 22.22 into 10 plus 0.5 into 0.444 into 10 square equals to, so the distance moved with the further accelerating the vehicle is 244.4 meter, okay, in 10 seconds. Okay, so this is the final answer. So we have solved both the cases, right? I hope you understood. Thank you.